In this video, I'm going to show you how to send logs from a Ubuntu machine to a Splunk server. But we're going to do it with a bit of a twist. We're not going to use the GUI and we're not going to use commands in a terminal. Instead, we're going to do this the professional way, with configuration files. Configuration files are how pros manage dozens up to hundreds of servers. I know this because I've worked in an environment like this running Splunk at a very large scale. Once you truly understand this configuration file method, managing either 2 or 200 servers becomes little more than just a method of copying and pasting. And if your goal is to move from a home lab into a real SOC engineering role, this is a very critical mindset shift. Learning how to manage multiple endpoints via configuration files is a foundational skill that will cross over into many other security tools. And it's one of the fastest ways to level up your security engineering game. So let's get started. Now to start, we need to set up our Splunk server to receive logs. We're going to do that by editing some config files, and to keep our permissions straight, we're going to go into the Splunk user again. So we'll go sudo su splunk, put in password. Now we are going to open up opt splunk etc system local indexes.conf. So we'll go vi opt splunk etc system local, and we are going to create a config file called indexes.conf. Actually, this is already made. So you can see that's kind of what it looks like. You can probably recognize this from video 2. So we are going to press O or I to insert, and then I'm going to copy and paste some lines in here. And I'm going to leave these in the description below so you too can copy and paste these lines. And basically what this is doing is this is setting up our Linux index, and it's telling Linux where we want all of the event logs stored. So we'll hit escape to get out of insert mode, hold down Shift ZZ to save and exit. Now we need to configure inputs.conf. So we'll do the same command, but instead of indexes.conf, we'll configure inputs.conf. And I am going to copy and paste some more lines in here. And again, these will be in the description below, so you too can copy and paste these. And once again, like in the last video, instead of going through here and explaining each line, which would make this video very long, I just put in a bunch of notes here for you guys to read at your leisure. So I'll hit escape, hold down Shift ZZ to save and exit. Now we are done editing our Splunk config files, so we're going to type exit, and then we are going to restart the Splunk daemon, or the Splunk service that runs Splunk in the background. So we'll go sudo systemctl, which is the way we interface with systemd. If you don't know what that is, don't worry about it. You can just type out this command the way I'm doing it. Restart splunk.service. And this should take a little bit, so if it takes too long, I will skip us ahead in the video. All right, there we go. It's done. Now, basically in inputs.conf, what we did is we told Splunk, hey, listen on port 9997 for incoming data and make sure that it's TCP. So now that we told Splunk we want that done, let's validate that Splunk is indeed listening on port 9997. So we'll go sudo socket statistics lntp grep 9997. And you can see here that on port 9997, the Splunk daemon is indeed listening. Let's go ahead and zoom in a little bit there for you guys. Let's go one more. Okay, so that part is done. Now let's open up our Ubuntu target machine and configure that. All right, nice and big. Should not have trouble seeing at all on this. Okay, so like I said before, now that we've told our Splunk server how to receive logs and where we want them to put them, we need to tell our vulnerable Ubuntu target machine which log files we want monitored and where to send the events from that log file. After we do that, we'll validate that events are indeed flowing into our Splunk server. And once again, as a reminder, skipping steps could lead you to a lot of painful troubleshooting later. So pay close attention to exactly what I'm doing and why I'm doing it, and I'll walk you right through it. So because we are changing Splunk configuration files again, we want to be inside the context of the Splunk user. So we'll go sudo su Splunk fwd. It's going to be Splunk fwd with our Ubuntu target because this is a forwarder. So fwd for forwarder. Okay, now we're in the Splunk user context. Now we are going to open vi opt Splunk Forwarder etc system local, and we are going to create a file called outputs.conf. Now you may look at this and you may go, well, wait a minute, didn't we configure a file called inputs.conf earlier on the Splunk server? And you'd be correct. And when I first started managing Splunk, I was actually really confused about inputs and outputs.conf because I would be thinking, well, wait a minute, inputs.conf isn't that what I want to send into the Splunk server? So shouldn't I configure inputs.conf to tell Splunk what I want it to take in? But that's the wrong way to think about it. The real way you should be thinking about it is inputs.conf, and when it gets really simple when you think about it like this, when you frame it like this. Inputs.conf, you're telling Splunk what you want to send into the Splunk daemon or the Splunk service, or just into Splunk if you want to say it like that. Outputs.conf is what you want to come out of Splunk. Okay, so inputs.conf is whatever you want to send into Splunk. Outputs.conf is whatever you want to send out from Splunk. And it's helpful, once you understand what a Splunk daemon is, it's helpful to think of inputs.conf is what goes into the Splunk daemon. Outputs.conf is what comes out of the Splunk daemon. The Splunk daemon is just the Splunk service running in the background. Okay, now that that's talked about, we'll open this up. I'm going to copy and paste some more lines in here. And you can go ahead and read through these comments at your leisure. But essentially what we're doing is we're saying, hey, this is outputs.conf, Splunk Forwarder. Send all of your event log data to this IP address at the bottom here and this port 9997. That's really all that this config file is doing. So we'll get out of this by hitting escape, hold down Shift ZZ to save and exit. And again, that will be pasted in the description of the video. Now we're going to configure another inputs.conf. And we're going to copy and paste some more lines. And this is essentially, we're telling Splunk, this is the log file we want you to monitor right here. varlog auth.log, because this log file records secure shell or SSH events. Oh, and then we're telling it, hey, put those events into the Linux index and label them with this source type, Linux secure. So we'll hit escape, hold down Shift ZZ to save and exit again. Now, because we are finished with our configuration changes for the forwarder, we're going to type exit to go back to the normal user context. And then from here, we are going to restart the forwarder. Restart Splunk, because remember, the forwarder has the service file in uppercase for some reason. Splunk forwarder.service. and then that will take a little bit to restart. Okay, now that that part is done, let's go to our Splunk server and validate or verify that logs are indeed flowing. So we'll open up Splunk, put in our username and password that we set up in the previous videos. We'll go to index equals Linux. 202 events. All right, we got logs flowing. Let's see, what do they say? Let's look at this one. Auth.log, systemctl, vero, root, sudo. Interesting. It's coming from our Ubuntu target machine. So we do indeed see event logs flowing from our vulnerable target machine into our Splunk server. Now, I don't know how you feel about this. I don't know if your accomplishment of getting event logs flowing from a host machine to a Splunk server feels like a big accomplishment, but give yourself a little pat on the back because this is not easy. This stuff is, can get messy and complicated really fast. And now you've got it up and running and working. So good on you. Okay, now that we've done that, the next step, because we are going to be brute forcing the SSH service later on our Ubuntu target machine, the next step is we have to install SSH. So if you fail to do this, the last part of both this video and even later videos won't make any sense. So let's make sure to perform this vital step right now. So we'll go sudo apt update. Again, we're just updating definitions or updating and telling Ubuntu what's available to it. Then we are going to do the command to actually install OpenSSH right now. So we'll go sudo apt install tac y to automatically respond with yes to any prompts. SSH server and hit enter. And then it's installing. Shouldn't take too long. SSH is not big. Let's clear our screen so you guys can really see. Now we will enable SSH. Systemctl enable SSH. This is just creating the SSH service file for those who know what that is. If you don't know what it is, don't worry about it. You'll be just fine just following along, doing what we're doing right now. You don't need a thorough understanding at this point. If you haven't seen or understood this by now, in IT and cyber, you are always learning. You never stop learning. So if you see something really quick that doesn't make sense to you, definitely be curious, definitely check it out, but don't let it trip you up like, oh no, don't cave in on yourself in your mind and go, oh, I don't understand that. I'm not perfect for this industry. No, you are perfect for this industry. Okay, you are. There is a lot to learn. Okay, where were we? We just did enable sudo systemctl start SSH. And now let's check the status of the SSH daemon. There we go. Active and running. You can see it right there. We'll hit Q to get out of that, just using the Q key. Okay, now we want to validate that SSH is indeed listening, like we did earlier with the Splunk server listening on port 9997. Now we want to be sure that SSH is listening now that we've set it up. So we'll go sudo ss for socket statistics, struggling with that one, lntp grep SSH. All right, there we go. It's listening on port 22, and it's the SSH daemon. Great. And if you're wondering, the L stands for listening. Give me listening ports only, or sockets more specifically. N means don't try to resolve names, just give me the IP address. Don't try to go out to DNS and resolve any host names. The T stands for TCP only. Don't look at UDP, TCP only. And P means give me the PID or process ID that is actually using the socket. All right, now that we have that set up and running, and we've validated that SSH is indeed listening, let's go to our attack box on Kali, and we will attempt to connect with SSH. Let me see. There we go. That's big. That's probably big enough. Let me know if that's not big enough. SSH Vero. Oh, you guys are going to want to do this. Let's go back. Ubuntu target. Let's make sure we know what our IP address is. 192.168. Your IP address is probably going to start with this. It's either 192 or 168, or it might start with a 10 dot something. And then these last two octets, this is an octet, this is an octet, but these last two octets are probably going to be unique to your machine. So mine is 229.141. And then we'll go back to our Kali attack box. We'll go SSH user Vero, because user Vero exists on the Ubuntu machine as well. 192.168.229.141. Uh-oh, keygen. I know what the problem is. The problem is that I connected SSH to this Ubuntu machine before, and then I removed SSH so I could show you guys a fresh install. And I didn't clean up the Kali box. So off screen, I'm going to clean this up really quick and get us right back on track. You don't need to know how to do this in order to set up your lab. So I'm just going to go ahead and do it off screen. Give me a minute. Okay, that should fix that. Let's clear our screen again. And then we'll attempt to SSH into our machine again. There we go. Now it's saying, hey, this is a new key. Do you want to connect? Yes. Okay, what's Vero's password is what it's asking right here. All right, we are connected. You can see here, Vero at Ubuntu target. So my prompt was this, just Vero. But when I SSH into the Ubuntu box, it becomes this. It says Ubuntu target. And how is that done? If you haven't seen before, you go to vi bash rc, go to the bottom, and then there's this ps1 variable. I will take this, and what this does is this says, hey, when somebody logs in to the machine by logging directly in and opening a bash terminal, show their prompt with just the username. But when somebody SSHs in, show the prompt with the username and hostname. So that way they know they're SSH'd into a different machine. And so to do that, you need a special prompt variable value like this. And so I will take this and I will paste it in the description so you too can put it in your bash rc file. So we'll get out of that. We'll clear our screen. So we see that SSH works. So that's awesome. So now let's go back to our Ubuntu machine and we will validate, or at least look at the connection. I'm going to back this off a little bit here to clean up the lines. But basically what you see here, here's my attack box IP. And this is the time I logged in. I'm logged into SSH. That's the SSH daemon. And then we'll zoom back in here so you can see better. And then we will go socket statistics as well. We'll look at it another way. We'll back off a little bit here. And you can see right here that I am connected from this Kali box at .136 and port 38558. and I'm connected to the Ubuntu target machine at this IP address and this port. So this is the IP address, this is the port, and together, both of them together, is called a socket, if you didn't know. Okay, now we validated that we can see our SSH logins. So now let's validate that we can see this SSH login reflected on our Splunk server. After we validate that, we'll have a bit of fun too by throwing a brute force attack at our Ubuntu target machine really quick, and we'll observe the events being generated by that attack in our Splunk server as well. So let's go to our Splunk server. Where am I here? And we will go to, we're in index equals Linux, that's what we need. We'll do source type equals Linux secure, and then we'll do a search for accepted password. All right, accepted password. Accepted password for Vero from 192.168.229.136, port 38558 SSH. Okay, so our login to our target machine, our Ubuntu target machine, that event was sent to our Splunk server. That is awesome. Okay, now for some fun. We'll throw a quick brute force attack at our Ubuntu target machine and verify that we can see those events being generated by the brute force attack in our Splunk server. So we'll validate that the event or events of the Kali box attacking the Ubuntu target machine, those events will be generated on the target machine and sent to our Splunk server for safekeeping. So we'll do a attack with a tool called Hydra, which is a common brute force attack tool. Hydra is a very, very cool tool. So we'll go Hydra Hydra uppercase I, which means ignore any previous progress files. If you don't know what that is, don't worry about it. It just means, hey, if you were running a brute force attack against a machine and you stop in the middle of that, Hydra will try to save your place. It'll try to save the location of wherever it was at in that brute force attack, and it'll try to just pick up from where it left off, like a bookmark for a brute force. Isn't that handy? A bookmark for a brute force. So the dash uppercase I just says, ignore those progress files, we'll just start a fresh brute force. And dash uppercase V stands for very verbose, so show every guess, every password guess, show it to me as you're guessing. And then we'll do dash L, which means login name, administrator. We'll give that as the login name. And then we'll do dash uppercase P. Here is a password file. So this is just a list of a bunch of different passwords to try on our brute force attack. And we're using the rocku.txt file. We'll go T2, and that stands for 2 simultaneous tasks or login attempts at the same time. So just going bang, 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 bang with 2 different passwords. So 2 simultaneous password attempts at the same time. Ooh, say that 5 times fast. And then an uppercase W. And that just means when we put the 3 with it, that means, hey, wait for 3 seconds between each attempt. Because if you're throwing like password guesses at SSH like 10 every second, SSH is gonna see what you're doing, and it has safeguards. You'll trip those safeguards and it'll go, oh, somebody's brute forcing me, I'm gonna lock you down. So if we slow down our attempts a little bit, and I mean 2 attempts every 3 seconds is pretty fast, but still it's slow enough that SSH might not natively recognize it as a brute force attack. Okay, enough talk. So after that, we do SSH / 192.168.229.141. And I just realized I am setting up this attack on our target machine. And I don't want to do that. I want to do this from our Kali attack box. So let me take this command that I've just beautifully explained to you and taken all this time, and let me put it in our attack box. Okay, there it is. Oh, here we go. Starting it up, doing some attacks. You can see it's trying user administrator, password rockyou, password abc123, password Nicole, password Daniel, all with the username administrator. Monkey, baby girl, Jessica. Jessica's a common password? Oh, okay. Learn something new every day. Okay, now that that is running, we'll give it a little bit longer. Let's go ahead and stop that because I don't want to blow up my lab quite yet. And let's validate or verify that we can see this in Splunk. Linux secure. Instead of doing accepted password, let's search for the phrase failed password. 28 events. Look at this. Here it is, guys. Failed password. Invalid user administrator from 192.168.229.136. That's our attack box coming from port 54446 via SSH. Here's another one, failed password for invalid user administrator from our attack box. Notice that the port, notice that the IP stays the same each time, but the port will change. Interesting behavior, huh? Hydra is changing the port, but not the IP. All right, great. Your lab is up and running and working. At this point, we're collecting the right data. In the next video, we'll turn that data into a real threat detection with our first Splunk alert. You've seen and done a lot, and you're learning a ton about being a real security engineer. Now on to the next video.